Hey, I'm Derek Hall. In this video, I'm going to do a fairly comprehensive comparison of gas-powered and electric vehicles using facts, logic, and numbers. I'm going to start with one of the most obvious numbers, the purchase price of a vehicle. Now, this Car and Driver webpage shows the initial purchase prices of 4 vehicles. And this confirms what a lot of people already know, that electric vehicles tend to be quite a bit more expensive than their gas-powered counterparts. Now, this webpage goes on to analyze the likely overall cost of purchasing and owning each of these vehicles for several years. And it determines that the costs largely even out over that time period between gas and electric. Now, that may or may not be accurate. It depends on a number of assumptions and estimates, notably gas prices, which tend to be very volatile these days. And it generally depends on how people use their cars. Now, when you're making any purchase, cost is only one side of the equation. The other side is benefits. What capabilities are you actually getting out of the product you're paying for? If we scroll down the page just a little, we see the F-150 Lightning has a range of 230 miles. The sources indicate the gas-powered F-150 tends to have a range of about 550 miles. That's a huge difference in the performance you're getting in exchange for what you're paying. And if you want to tow a trailer with an electric truck, that takes a big toll on the range as well. People have reported up to a 25% reduction in the range of the F-150 Lightning when it's pulling a heavy load. And that, if that's true, that would bring it down below 180 mile range. And that's a general trend, that electric vehicles tend to have much shorter ranges than their gas-powered counterparts. And that should be considered in addition to the complication of having to find charging stations and then waiting long periods of time for the battery to charge. And next, I'm going to get into some technical details that help explain some of the differences between gas and electric vehicles. This is a web page that analyzes the Tesla battery cell, and it has determined that the energy content is almost 300 watt-hours per kilogram, and that's about the best that an electric vehicle battery can do these days. So I'm going to use that number in the spreadsheet that I've made comparing gasoline and batteries. So I have the 300 watt-hours per kilogram here for the battery. Gasoline has about 13,000 watt-hours per kilogram. So it's really no contest here. That means a battery has to be many, many times heavier than gasoline just to equal the energy content. And that's why electric vehicles tend to have trouble getting good range and tend to be a lot heavier than gas-powered vehicles. All of the Tesla model cars weigh over 4,000 pounds, and the Model S actually weighs closer to 5,000 pounds. That Hummer EV model actually weighs 9,600 pounds. So electric car batteries, along with being very expensive, are also very heavy, which can cause issues. Also consider the life of your tires if they constantly have to support all that weight. The next thing I'm going to do is compare the cost of recharging a battery to the cost of refueling with gasoline. Now, the row I have selected here shows a recent national average cost of electricity charged by utility companies. You could charge a car at home, but you have to buy the charger, which can be quite expensive, and you have to install a special outlet to plug the charger in. And that may or may not be possible for a certain home, and you may not be able to do this at all if you don't own your home. Then you have to resort to charging stations, which can be quite a bit more expensive, as shown here. Now, this is a recent national average cost of gas, which doesn't really offer us an apples-to-apples comparison, but you can use the energy density of gasoline, which happens to be about 36 kilowatt hours per gallon, to convert to a gas cost per kilowatt hour. So it's the same units as the electrical cost. So you get this number right here. You might say this is a bit low. It seems unrealistic. It's even lower than this. That's where energy conversion efficiency comes in. This is where electric vehicles tend to have a big advantage. These energy conversion numbers are approximate, and they're also realistic. And I've chosen them specifically to have a 4-to-1 ratio, because that's often how it is in real situations. I'm back on the Car and Driver webpage from earlier, and this is the energy usage section. Now, you could use that gasoline energy density of 36 kilowatt hours per gallon to convert this number and this one to kilowatt hours. And then you can compare each pair. And you will see that the gas-powered Hyundai uses about 4 times the amount of energy compared to its electric counterpart for 100 miles of travel. And the gas-powered Ford F-150 uses a little less than 4 times the amount of energy to go 100 miles compared to its electric counterpart. So in both cases, it's pretty close to 4-to-1 ratio. I just wanted you to see that. Notice that when somebody points out the difference in energy content between gasoline and batteries, electric car activists are very quick to point out the differences in energy conversion efficiency. So let's factor that in because it is important. Now the rows I've selected here show all the adjusted numbers based on the energy conversion percentages above. By the way, a lot of people are referring to this as energy density. If it's energy per unit mass, I believe it's more appropriately called specific energy, so that's what I'm calling it here. So the specific energy numbers are closer than they were, but this is still a big difference. This is almost an 11-to-1 ratio. And just to be clear, this is the amount of energy that actually gets converted to mechanical output per kilogram of the source. Electric charging costs go up a little bit with energy conversion factored in. The gas cost per gallon stays the same as above. And this is the energy density of gasoline based on mechanical output energy per gallon. And once again, you can use these two numbers to calculate this number, the gas cost per kilowatt hour. You can see it's a lot higher in this case. It's almost exactly the same as the charging station cost. One other thing in this spreadsheet, since gas prices are so volatile these days, I wanted to show what the calculation will look like for gas cost using the national average from December 2020, when our energy policy made a lot more sense than it does now. So in December 2020, that average was about $2.28 per gallon. And if you use that and this energy density number once again, you come out with a gas cost per kilowatt hour shown here. This is a lot lower than it would have been here, and it's also a lot lower than the charging station cost, and it's a lot closer to the electric utility cost. Now, one really appealing thing about electric vehicles is that they can deliver a lot of power and torque without making noise, and that's consistent with the high energy conversion efficiency. Now, that's the main reason I've considered buying an electric vehicle. They can be fun to drive, but then I got to consider the other factors too. Now there are a few other things I want to briefly mention. Now, this same Car and Driver webpage from earlier also discusses the likely maintenance costs of the 4 vehicles shown, and it shows that the gas-powered vehicles are likely more expensive to maintain than the electric vehicles. There are probably a number of assumptions in these numbers too, so that's got to be kept in consideration as well. Now, my biggest concern regarding electric vehicle maintenance would be battery performance, lifespan, and potential complications. Car and Driver has a write-up on EV battery life, and I have that on the screen right here. Now, the federal government does require car manufacturers to provide at least an 8-year, 100,000-mile warranty on all electric car batteries. And I'm a little suspicious as to why the government feels the need to require that. But then it's one of the many ways that government puts its thumb on the scale in favor of electric vehicles these days. So this webpage lists several benefits of lithium-ion batteries compared to other battery types. And the last pointer says it provides more consistent voltage even as the charge degrades. But even lithium-ion batteries experience some decline in voltage and therefore some reduction in max power output as the charge gets used up. So if you're experiencing less power when you push the accelerator, you may want to find a place to plug the car in and recharge it. Now, gas-powered vehicles, on the other hand, of course, deliver the same max power output regardless of how much fuel is in the tank, as long as there's some fuel there. Also, as mentioned right in here, an electric vehicle battery's charge capacity also declines over time as it undergoes numerous charging cycles. And with that, the vehicle's range also declines. And by the way, it's the quick charging at charging stations that takes the biggest toll on the battery's life. Ultimately, all these batteries will eventually have to be replaced after a certain number of charge cycles, and someone will cover that cost. Either that'll be the owners of the vehicles or the manufacturers, and if the manufacturers have to pay for a bunch of new batteries, they're going to raise the prices of their vehicles to cover that cost. Now, on the same page, once again, we have a list of drawbacks of lithium-ion batteries. They're all important to consider, especially the first one where it says they're expensive to produce, and mining the raw materials can involve serious environmental and humanitarian concerns. This page identifies 5 critical raw materials needed for lithium-ion batteries, and the map down below ranks a number of nations based on their supply of those raw materials. As you can see, the United States is ranked relatively low, and China is ranked number 1. So along with serious environmental and humanitarian concerns associated with mining the raw materials. It also creates complicated supply chain issues, which makes the United States more dependent on other nations for energy. I'm definitely in favor of pursuing new ideas to the extent they make rational financial and economic sense. But gasoline and diesel fuel are both extremely dense energy sources. The United States has ample opportunity to produce enough of those fuels to be energy independent. So an overall transition to electric vehicles makes no sense. Now, just to summarize a few key points, electric vehicles are generally more expensive than their gas-powered counterparts. Gasoline has a much higher energy content per unit mass compared to batteries. That means batteries are very heavy, and electric vehicles tend to get less range than their gas-powered counterparts. On the flip side, electric vehicles tend to have very high energy conversion efficiency and can output a lot of power and torque without making much noise. It's also important to consider all the possible complications involving batteries and their supply chains. A lot of research really should be done to try to figure out a better way to store a lot of electrical energy in electric vehicles. And that should be done before jumping too far into mass production of electric vehicles. But then again, it's mostly government and policymakers that are pushing the move toward EVs instead of letting the market decide on its own. But I do believe the market's true desires will ultimately prevail. Anyway, thank you for watching this video. If you enjoyed it, please let me know and be on the lookout for my next video. Thanks.